So we're going to take a bit of time now to have a look at multiplication of fractions. And the good news is it's actually a lot easier than addition of fractions for a few reasons. So remember when I said the denominator stays the same? Well, in multiplication it doesn't. So if you have a look at what I've got on my page right now, you can see that it's just straight out multiplication across the numerator and the denominator, and you end up with the answer. Still has all the other things like cancelling and so on. You've got to factor those things in. No pun intended. But the actual calculations, there's nothing to really remember except your times tables. Okay, so let's have a look. So the example that I had above was 1/3 times 1/9. So first thing I'm going to do is a straight out demonstration of what to do, and then get into the whys of why it works. So unlike the addition and subtraction, we don't have to worry about the denominator being the same. You just do it like this. 1 times 1 is 1, 3 times 9 is 27, 1/27, and that is finished and correct. So you simply multiply the top, multiply the bottom, whatever you get, and the question is finished. So that's what you do. You multiply the numerators and the denominators, and you simply write down the number. All right? So you can finish now. If you want to stop watching the video now, you know how to do it. Okay? But I'm going to spend a few more minutes now getting a little bit further into it, giving you some important bits of information that'll really help you understand why it works the way it is, and do some significant maths vocabulary in relationship to this topic. Okay, so hopefully you'll stick around for that. But if you just want to do it, yeah, go do it. And so all the really intellectual ones are still with us. Excellent. All right, so let's have a look at why this works. So a piece of crucial vocabulary here. So you can think of this as 1/3 times 1/9, but you can also think of it as 1/3 of 1/9. So the multiplication symbol can often be said as of, 1/3 of 1/9. What does that mean? Let's have a look. So this is 1 square. What would 1/3 of 1 be? So we take 1 square and we divide it up into 3 equal parts, and we colour in 1. So that's 1/3 of 1. With me so far? Okay. What about 1/3 of 1/9? Okay, so this is 1/3 of 1. What about 1/3 of 1/9? So we've got to take 1/9 and divide that up into 3 parts, the way we took this 1 square and we divided the square up into 3 parts. So in order to take 1/9 and divide that into 3, first we have to have 1/9. So let's make 1/9. I'm going to do that by drawing a much bigger shape. So that should be 9 across. And so that's 1. So I'm going to take this 1 and now I'm going to make 1/9. I'm going to draw these lines down here. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So each of these is 1/9. Get it? 1 out of 9. So let's take one of the 1/9. We'll take this one. And we're going to cut that into 3 parts because we want 1/3 of 1/9. So I take this 1/9 and I cut it into 3. Now because I'm dealing with fractions, I've got to cut the whole thing. I've got to have equal parts inside the shape. I'm not allowed to have unequal parts. So I'm not really allowed to do that. Okay? That's not on. I've got to have equal parts. So to make equal parts, I do it to the whole shape. All right? So now this 1/9 has been cut into 3 parts. 1, 2, 3. And so we have 1/3 of 1/9. 1/3 of 1/9 would be one of these. So what fraction is that? Well, how many of these do we have? Well, we count the whole thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So this is one piece out of 27. So if I take 1/9, which is this, and cut it into 3 to get 1/3 of 1/9, I'm left with 1/27 or 1/27th. And you can see that that completely confirms our calculation. And this is the reason why it works the way it does. So when we multiply fractions, you simply multiply the numerators and multiply the denominators and you get your answer. And this is the reason why it works the way it does. So that's the rationale behind it. So let's get some practice and have a look at some variations. So let's do 3/7 times, that's very badly done, times 1/5. So really simple to start with. 3 times 1 is 3. 7 times 5 is 35. 3/35. So there's your answer. When you get to this point, this is where you've got one more thing to do, maybe. It depends on the numbers. So you've got to try, if you can, to cancel it down to the lowest common fraction. And the way you do that is by asking a couple of questions. So the first question is, take a look at this number. Take a look at this number. Will the numerator go into the denominator? It will if the numerator is a factor of the denominator, or putting it differently, if the denominator is a multiple of the numerator, 3 and 35. Well, how do you work it out? Well, you've got to sort of set out your factors and multiples for the numerator and the denominator, and if you find that there's one in common, then one will fit in. So I'm having a look at the numerator, and I'm seeing the number 3, so I'm thinking, oh well, I'll write out my 3 times table. Now, of course, if you know your tables, you just do this in your head. You know, that doesn't work. But I'm going to go the long way, just for the practice. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, and we do not stop at the 35 stop, so it does not. They're not common factors, common multiples of each other, so it's no good. We're down as low as we can go. There's something else that's a little bit of a clue to that, and that has to do with this number 3 here. It's a prime number. So if I look at the factors of 3, so here's the number 3, how many factors has it got? It's only got itself and 1, 3 times 1, it's prime. So I can't really break the 3 down into anything smaller. So that's why, unless the 3 fits into the 35, I'm down as low as I can go. But what about if we tweak it slightly, just to show something else that you can be thinking about? So I'm going to use almost exactly the same question. What about 3/7 times 1/3, 1/3? This might be a little bit different. So let's do it. 3 times 1 is 3. 7 times 3 is 21. Same question. Will this go into this? Well, I think maybe if you know your 3 times table, you know that 21 is in there. 3, 6, 9, 12, 15, 18, 21. So I can cancel it down. 3 into 3 goes once. 3 into 21 goes 7 times. So now it's 1/7. And 1 is pretty much the lowest you can get in terms of a numerator. So there's certainly nowhere else to go, 1/7. There's just one more thing that's worth exploring. And so I'll just choose a different one. Let's do 4, oops, I might just redo that one. Let's do 4/6 times 5/8. So it's pretty substantial. Okay, so here's where things can get a bit more complicated. Depends on what you want to do and how much you want to remember. Firstly, if you just want to straight out multiply it, yep, that's fine, and you'll definitely get the right answer. But you might want to think about doing a few preparatory steps. What do I mean by that? Well, you don't have to save your cancelling down to the end. You can do it before you start. And that way these numbers end up being a lot lower because you're cancelling down to lower numbers. For example, 4 over 6. So does 4 go into 6 evenly? No, it doesn't. But what about thinking about the factors of 6 and the factors of 4? Is there a common factor? Yes, it's 2. 2 into 4 goes 2 times. 2 into 6 goes 3 times. And now we're down as low as we need to go. And now I can do my multiplication. 2 times 5 is 10. 3 times 8 is 24. And I've already got a much lower number than the one I started with, 10 over 24. I'm not done, and I'm also not going to continue because I'm going to show you what happens if we don't do that. So I'm just going to undo those steps and just stick with my original question as written. 4 times 5 is 20, and 6 eighths are 48. 20 over 48. Now, if you're looking at 20, does 20 go into 48 evenly? No, because 20 and 20 is 40, and there's 8 left over, so that's no good. But there's something else about them that might be super helpful. What is it? Think of the factors of 20. Think of the factors of 48. Okay, so a couple of different directions you can go here. First, you might say, well, they're both even, so they both have 2 as a factor. And you could start going down that track and you'd be fine. Okay, let's do it. 2 into 20 goes 10. 2 into 48 goes 24. Oh, look what we've got. Good old 10 over 24, which is where we were before. And we can keep going via 2, right? 2 into 10 goes 5. 2 into 24 goes 12. And now we've got 5 over 12. Look, 5 is prime. So it's not going anywhere unless it fits exactly into 12, and it doesn't. So we're done, 5 over 12. Okay, but we had a bit of a road, didn't we? Had to do all of that. Is there a better way? I'm glad you asked. So what else could we have done? Let's go back. And as with almost everything at this point, if you know your tables, this next step is much easier. So now we're going to think about 20 and 48 in a different way. We're going to think about them in terms of factors. What are the factors of 20 and the factors of 48? If you're really good at your tables, you can do this in your head. But I'm going to go the long way. But if you've got a good grasp of your tables, you think about, well, which table is the number 20 in? Which table is the number 48 in? Is there a common element to that? So what I'm doing in my head is kind of what I'm about to do on paper. So let's think about the number 20. How many different ways can we make 20? Well, let's think. I'm just do it randomly. 2 times 10 is the one that sort of comes to mind first. But there's also 4 times 5. And there's 20 times 1. Okay, so there's my factors of 20. If I sort of wrote them out in numerical order, I would have 1, 2, 4, 5, 10, and 20. So I'll do the same now with 48. Yeah, it's a big number, probably going to have a lot of different combos, so let's start thinking about them. Well, let's get this one out of the way. 1 and 48. 1 times 48. There's 24 times 2. There's 6 times 8. 6 eighths, 48. And there's 12, 24, 36, 48. So that's 12 times 4. What else? Maybe there's more. Yeah. Now I think maybe I'm at the end. So let me just write them out numerically like I did with the 20s. So let's do them in order. So you got 1, you've got 2, and it doesn't seem to have 3. I wouldn't be surprised if 3 went into it. Let's find out. 3 into 48. 3 into 4 goes once with 1 left over. Yes, 16. 3 and 16. So there's 3. There's 4. There's not 5, but there's 6. There's not 7, but there's 8, 9, 10, 11, 12, 16, and 48. All right, now there's a video that we talked about the lowest common multiple. This time, to get the cancelling down done as quickly as possible, we want the highest common factor. Let me write that down. Highest common factor. Oops. What's the biggest one? Because the biggest one gets us cancelling down the fastest. So let's have a look. Well, they've both got 1. They've both got 2. This one hasn't got 3, so that's no good. They've both got 4. And that's it. 6, no. 8, no. 6, no. All right, so the highest common factor is 4. So we're going to put 4 into the numerator and the denominator. I'm just going to clear some space. Okay, that's looking a bit tidier. So now I'm going to put 4 into both of the numbers. So 4 into 20 goes 5, and 4 into 48 goes 12. And lo and behold, guess what we've got? We've got our 5 over 12 again, just like before. So because I had my highest common factor, I could do that calculation super fast. If you know your tables, you can find the highest common factor fairly quickly. For example, if you know your 4 times table and your 12 times table, bang, you're there. Or if you know your 4 times table, but if you know your 4 times table up to 12 times 4. So that's the use of the highest common factor. And once you've done your multiplying of fractions, usually in an assessment, they want you to cancel it down. Sometimes they'll say don't do it. Sometimes they'll say they want it. And sometimes when you're using them in a practical situation, for example, if you're measuring something, then you probably would want to know the smallest. But you may not. If it's cutting up a cake or something, that might be different. Okay, so good luck, and have a go at some of the questions that are attached to this video. That's if you're doing it in the Google Classroom environment. If you're just listening to it for a bit of knowledge, great, that's fantastic. You can easily go onto one of the many websites and download some of these and practice them and see how you go. Okay, thanks, and see you next time.